Okay, so we're going to do a transformation of curves question. You can find this question on a GCSE higher paper towards the very end, or on a Core 1 AS paper. So we're given a sort of classic problem, given a quadratic equation. See, it goes to the y-axis at 5, the x-axis at 2 and 4, symmetrical around 3, and its minimum point is at 3 minus 2. That's for the value x equals 3, the lowest function value of y is minus 2. It never goes lower than that. And we've been asked to perform two transformations, and so I'm doing these two together with a purpose, so it distinguishes between f of x as the function first, then add 2 onto it, in fact, leave that bracket there, and then f of add 2 to the value of x before you put it through the function. So two different types of transformations. So if we look at do the function value first, then add 2 to it, then the impact of this would be to, if we put 3 in, we're going to get minus 2, because we can see from here that f of 3 equals minus 2. But then we have to add 2 to it, so it's going to lift the point 3 minus 2 up to 0. It's usually in these questions just to ask you to plot where it cuts the axes. So we've moved the bottom point up to touch the axis, so we now only touch the axis in one place. Now what would have gone through 5, so when we put 0 through, we will get 5, but in the transformation of x plus 2, we've got to add 2 to that, so it will go through 7. So your transformation will look like this. And these type of transformations are really the easiest of the lot. If we're adding something to our function, it's positive, it moves up by those number of units, or if it's negative, it would come down. And in this particular case, we move our lower point up to touch the axis in one place. So if I was asked to write the coordinates there, it would be 3, 0. Cut the y-axis now at 7, 0, 5. So if we come across to the type that looks similar, but it's not the same, what we're doing here is we're putting in the value of x and then adding 2 to it. So if I want to cross the axes at 5, then I'm going to need to put in the value of x. So if I want the point 5, shall I say, if I want the value of 5, then I got that in the first function from putting in 0. If I put 0 into this, and I add 2 to it, I'm going to get the value that was at 2. In fact, what we can see, when we put 0 through, we're going to get the same previous value that we had at 2. So the impact is to move the graph that way. Okay, so I'll just run through that point again. If I put 0 in here, I choose x to 0, and I add 2 to it, that's exactly the same as f of 2, and we know that f of 2 is 0. So, and these are just reminders, these short videos really, so if you remember with this will bring brings our graph across 2. So what was at 4 will go across to 2. And in fact, at minus 2, we will now have the point 5, although on a sketch, I'm not really going to use them. Come round and back. So here's our f of x plus 2, and it's a shift to the left of 2 units. So again, so this was up by 2, and this is left by 2. And that covers the first of 3 videos I'm going to do on transformation of curves.